Well, hey, Living Environment fans, good to see you again on this Wednesday. Now, normally Wednesday would have a book talk, but not today. I put the Hot Zone Part 6 in the classroom for next week's book talk. So, yeah, I know it's kind of a bummer, but I purposely didn't give you the book to read over the break so that you'd go on a break. And now we're back from the break. So let's talk cells and cells as factories, shall we?
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
I love the analogy of the cell as a factory. The cell is a membrane bound, right? Membrane bound, like it's an actual physical place, a cell. And what happens in cells, their primary purpose is to make protein. And they do it in a very efficient factory-like manner so that, the cell, different cells are different from each other depending on what protein they make. Like pancreas cells make insulin, but stomach cells don't make insulin, they make pepsin, right? Like we've studied that. Salivary gland cells make amylase enzymes. So how is a cell like a factory? That's kind of our essential question, and that's what we're studying this week. And one way to think of it is that cells are like factories because they take in raw materials from the environment and they process them into a product. And that product is packaged, stored, and then shipped away to wherever it needs to go. Like if you're a stomach and your stomach cell and you're gonna make pepsin, you need amino acids from the environment. You bring them in, and then you need workers, ribosomes, to put those amino acids together in the correct sequence in order to make pepsin. And then you wrap that pepsin up in a nice little membrane, and you keep it stored until food comes to the stomach, and then you dump that pepsin out onto that food. And then you do it again, right? I mean, that's what stomach cells do for their entire life. Okay, they're like factories. Now, the factories, of course, have management, and the management is in the nucleus. That's where decisions are made. And the nucleus has in it DNA, which has got the code, the chemical code to tell ribosomes how to put proteins together. And this, we're a little ahead of ourselves, but the copying down of the code is called transcription. And then the making of the protein is called translation. Right? Transcription and translation. So we'll talk about more about that later. Right? But think of cells as factories. Parts come in, they are assembled, they are packaged, they are stored, and then they are shipped out. All right? You need energy for this. That's why you have mitochondria on hand to make ATP. That provides the energy for the putting together of the pieces. You have a couple of other things going on too. You need to have advertising. That's part of the role of the antigen proteins and the glycolipids that are on the cell membrane. You need to have security, right? Just like the plasma membrane, it lets certain things in, certain things can't get in. And then of course you have to have some kind of maintenance. And in cells, especially animal type cells, we call those somes or lysosomes or peroxosomes, or it depends on what cell you're in. But their job is basically to go around and clean up things that are broken. So the cell is like a factory. Cell is like a factory. Hot dogs are made in factories. Doesn't that look yummy? Making the meat putty, the meat batter to put into those hot dogs and make those scrumptious, lovely pork, chicken, and beef flavored. Just watching hot dogs get made make me hungry. Yeah, put some salt in there. Yes, that's what we want to see. Yeah, really. Hot dog factory. Product comes in, right? Raw materials come in, and then it gets processed into a product, and that product are hot dogs. Cells, raw materials come in, they get processed into a product. That product is proteins. They're the same. Well, at least they're analogous, similar, analogy. Look at that meat batter. Doesn't that look scrumptious? I think so. I really do. Have a good lunch, everybody.